Hi, good morning to all. Today we are going to start with a new chapter, Chapter 5 States of Matter, which consists of four subtopics: gas, liquid, solid, and phase diagram. As students know, matter have three basic phases: gas, liquid, and solid. Now we are going to look at the gas. These are the learning outcomes we're going to cover under gas 5.1. General properties of gases. Gases occupy more spaces than their solids or liquids. Gases have much lower densities than solids or liquids. Gases expand to fill their containers, where they assume the volume and shape of their containers. Gases are easily compressible compared to solids or liquids. Gases flows readily. Gases mix completely and evenly when put together in the same container. 1 mole of gas occupies a volume of 24 liter at room condition and 22.4 liter at standard room temperature and pressure. Next is kinetic molecular theory of gases, which describes the behavior of an ideal gas. Ideal gas is a gas that obeys ideal gas equation. Ideal gas equation is PV equals to nRT. P stands for pressure, V stands for volume, N stands for mole of gases, R stands for universal gas constant, and T stands for temperature in absolute Kelvin or absolute temperature. Kinetic molecular theory of gases, the theory that explains behavior of gases, and they are made based on following assumptions. A gas consists of a very large amount of extremely small particles, molecules or atoms in constant, random and straight line motion. Collisions among molecules are perfectly elastic. Energy can be transformed from one molecule to another during collision, but the total energy of all molecules in the system remain the same. The volume of gas molecules are negligible compared to the volume of its container. Attractive and repulsive forces between molecules are negligible. The average kinetic energy of molecules is proportional to absolute temperature. A gas corresponding to these assumptions is called an ideal gas. Now we look at gas laws. Begin with Boyle's law. Boyle's law states that at constant temperature, the volume of a fixed amount of a gas is inversely proportional to the gas pressure. Students can see here, volume is inversely proportional to pressure at constant temperature and mole of gases. A molecular description of Boyle's law. This one is similar to our experiment 4, home-based experiment. Students can use the stimulator to learn this. So when the pressure, external pressure is increased at fixed mole and fixed temperature, what happened to the collision? We can see the collision increases. However, the collision only increases when the volume become lower. Meaning to say, when pressure increases, volume will become lower. Okay, then therefore we come to an expression or a formula that represents Boyle's law. P1 V1 equals to P2 V2. The parameters related here is pressure and volume. We can also interpret the formula in terms of graph. When we plot pressure versus volume, we get an inverse graph showing that as the volume increases, pressure decreases. Or we can also plot pressure versus 1 over V, which we get a straight line because pressure is directly proportional to 1 over V and pressure is inversely proportional to V. So this is two type of graph. The third type is when we plot PV versus P, where you get a constant graph. Now we look at example of calculation. A sample of chlorine gas occupies a volume of 2 liter at the pressure of 1 atm. Calculate the pressure of the gas if the volume is increased to 5 liter at constant temperature. Now, since they mention constant temperature over here, therefore we directly apply the Boyle's law. So P1 V1 equals to P2 V2. P1, as students can see here, is 1 atm from the question. And V1, 2 liter, is also given in the question. We need to find the P2 at 5 liter. 5 liter is our V2. So when we substitute all the values into the formula, We could find the pressure after the volume is increased drops to zero point 0.4 atm. Now let's look at example 2. The pressure of a sample of hydrogen gas in 50 ml container is 765 millimeter mercury. The sample is then transferred into another container and the measured pressure is 825 millimeter mercury. What is the volume of the second container? Now we are going to find the volume, the V2. So P1 V1 equals to P2 V2. Similar formula. P1 is 765 millimeter mercury, while the V1 is 50 ml given in the question. Now P2 is given to us as 825 millimeter mercury. So we have to find the V2, the volume which I got 46.36 milliliter. I would like the students to calculate again. Maybe the answer given here could be wrong. Please recheck when you do or you watch the video lesson. Thank you.